Welcome to section 4.2, day 1, point-slope form of linear equations. Today we are going to write and graph equations in point-slope form. The point-slope form of an equation of a linear function is y minus y1 equals m multiplied by x minus x1, where m is the slope, and x1, y1 is an ordered pair for any point on the line. Point-slope form is the third form of the equation of the line we are learning. We've already done standard form, and we did slope-intercept form, and now we have another one, point-slope form. This form is quite handy and can be used, very useful, when you're making equations of lines. One of those things people have a lot of trouble understanding where this comes from, but this point-slope form of an equation is actually derived from something we've already used. If you recall, when we did slope, we did m, our slope, was a y coordinate minus a y coordinate over an x coordinate minus an x coordinate. Well, to derive the point slope form, you just multiply both sides by x2 minus x1, not x squared, but x2. And when you do that, this cancels out on this side, and you're left with m times x2 minus x1 and y2 minus y1. Well, when we're doing this, we're just going to look for the general form of an equation. So our y2 just becomes a y, and the x2 just becomes an x. Come on. And this could be rewritten where we have the y minus y1 on the one side and the m times x minus x1 on the other. So the point-slope form of an equation of a line is derived from the slope formula. So if you ever forget what the setup is, remember your slope formula, and you can derive the point-slope form. So with the one below, we have write the point-slope equation of the line that goes through point 6, negative 2, with a slope of 7. So we're going to take y minus our y-coordinate, in this case our y-coordinate is negative 2, equals our slope, which is 7, and x minus 6. And what we will do is we will simplify this minus 2, and you can do this right away. We get y plus 2 equals 7, x minus 6. And this is the equation of my line. We're going to do the next one. It's doing the same thing. We're going to plug in our point. So our y-coordinate is 4, so y minus 4. Our slope is negative 1/2, and our parentheses is x minus our x coordinate, which is 3, and this is in point slope form. One of those things to remember is just like when we did absolute values, we have minuses in here, so make sure you keep track of your signs. So it's y minus y1 equals m x minus x1. Remember, there's minuses in there. The next thing we're going to do is we're going to take the point-slope form of a line, pull out the point, pull out the slope, and graph it from the point and the slope. Remember, our form is y minus the y-coordinate equals m x minus the x-coordinate. We're going to look for our point that we can pull out of our equation down here. And I'm going to look for my x-coordinate first. And we have x plus 1. We pull out the opposite sign. So instead of being a plus 1, our x-coordinate is at negative 1. And then we have y minus 2. And the form is y minus the y-coordinate. So we're just going to pull out a positive 2 for our point. And again, if you need to, you can take what's in the parentheses and set them equal to 0. And you'll get x is negative 1. You can do the same thing with y minus 2, set it equal to 0, and you get y is 2. So if you forget, you can always set what's in the parentheses to 0 and solve, and it'll tell you where your x-coordinate is. So we are going negative 1, 2. So we're going to go backwards 1, up 2. This is my point. And then we're going to use our slope, and our slope, our m, and this one is 2/3. So we are going to go up 2 over 3, up 2 over 3, and then we're going to draw our line. And there is my line in from the equation y minus 2 equals 2/3 x plus 1. So what's different on this one, instead of using a y-intercept to start, like we did in slope-intercept form, we are going to use a point, and from that point, we will use the slope. So the first thing we need to do is pull out the point, plot the point, and then use the slope from there. And again, just like we did at slope-intercept form, I want to see 3 points. So your initial point that you start with and 2 more. Let's go on and do another one. So here's another one. We have y minus 1 equals 2 times x minus 3. And again, remember the form is y minus the y coordinate equals mx minus the x coordinate. We are going to pull out the opposite signs. We're going to look for our point first. So our x coordinate, x minus 3, we pull out the opposite of -3 and we get a positive 3. We have y minus 1, we pull out the opposite sign and we get 1. So our point that we start is at go over 3 on the x and up 1. And we're right here. Our m in this case is 2. So we are going to go up 2 over 1, up 2 over 1, and then we are going to draw our line. So this is graphing from point-slope form. Pull out the point first, use that, and then from that point, use your slope. The last one we have is what is the equation of a line in point-slope form that goes through the points 1, 2, and -1, 7. Whenever we have to write the equation of a line, the first thing we really need to have is we need to have a slope. In this case, we aren't given a slope, so we need to solve for the slope first. So we're just going to use our slope equation. M is the y-coordinate 7 minus the y-coordinate 2 all over -1 minus 1. And we get 5 over -2. This is -5/2. We are then going to pick one of our points to use to write our equation. And again, remember it's y minus y1 is our slope, x minus x1. So we are going to plug in our point, and you can pick either point, it doesn't matter. I'm going to use the first point because the numbers are smaller. We have y minus 2 is y minus the y coordinate, is our slope, -5/2, and then x minus the x coordinate. This is one of the two solutions you could have. If you picked the other point, -1, 7, you would have y minus 7, y minus the y coordinate, is -5/2, and then x minus the -1 minus the -1 becomes +1. And you could have either of these two answers. If we were to convert this to slope-intercept form, they would both become the same slope-intercept form of the equation. If we converted these to standard form, they would both be the same. Because we're using different points, they look different, but actually they are equivalent equations. All right, so that is it for 4.2 day 1, point-slope form. The biggest thing to remember is the form of the equation is y minus the y coordinate equals m, and then x minus the x coordinate. On today's assignment for questions 5 through 10, only give me the point-slope form. It is going to ask you to write them in standard form and slope-intercept, but for today, for 5 through 10, just give me the point-slope form. Like I said, that is it for today. Thanks for watching and have a nice day.